Hi, we are the Geriatric Lemur team, and this is our final design video. Our final design was a ramp that was made in order to help geriatric lemurs move in the Duke Lemur Center.
Our final prototype is 20 inches by 50 inches. It was broken into 3 main design blocks: the legs, the frame, and the wire mesh. The legs and the frame were connected by PVC connectors, and the wire mesh was integrated using zip ties. Our final design is made out of 1-inch PVC for the frame and 1 1/4 PVC for the telescopic legs. We used thicker PVC in order to increase the stability of the frame. We used maritime coated mesh to connect the frame because it will withstand the cleaning solutions used by the Lemur Center. We added more holes to the telescopic legs as requested by the Lemur Center so the ramp could be used at more heights, and we fastened the mesh to the frame using zip ties. Our features of the design include the frame, which is used to support the wire mesh, and the lemurs crawl up and grip the wire mesh. The telescopic legs are used to adjust the ramp to the varying heights of the windows.
The nuts and bolts are being unscrewed to allow the telescopic legs to reach to the 48-inch window. The nuts and bolts are then being re-screwed in order to secure the legs so they do not fall back down when reached to their highest height. For our prototyping description, we began with a low-fidelity prototype for all of our possible solution ideas. This included an adjustable net ramp made of straws and pipe cleaners, as well as a ramp made of popsicle sticks. The purpose of the low-fidelity prototypes was to see the shape and function of what our solution would look like. We then moved on to a medium-fidelity prototype where we combined the adjustability aspect of the telescopic legs with the ramp frame and created an adjustable ramp made of 1/2 and 1-inch PVC pipe as well as nylon netting. This prototype allowed us to see the size of the solution, the angle of the ramp, and we were able to test out the functionality of the telescopic legs in order to see if it was adjustable. We then moved on to our high-fidelity final prototype, which we built in order to optimize the design we created using the medium-fidelity prototype. For issues and obstacles. First, our materials were not ordered on time, which led to a waste of class time and a waste of time in terms of prototyping and testing. This means we were not able to test as much as we would have liked for our design. Also, the wires were rusting at the Duke Lemur Center, and so we changed this by changing the cut of the mesh in order to make it one long strip rather than discrete sections in between each support beam. For our reflection. Overall, our project went very well. We were able to meet our deadlines in spite of setbacks with both materials and prototyping. Each team member was able to contribute meaningfully to our final design. Upon reflection, we could have used our time more efficiently in order to fully maximize the time set aside during our lab and lectures. Our communication with both our client and technical mentor, as well as within our team, was very good. We were constantly in contact to make sure that we could take advantage of the resources we had. Finally, we learned how to use power tools and 3D print in order to create useful prototypes, and finally, a final design that our client could successfully use in their center.